All right, if you haven't checked your answers, or if you're wondering what the answers would be for the polyatomic ions, the last two were carbonate and nitrite, they're on the answer keys that should be passed out by now, but they're over there next to the sink. So if you'd like to take a look during work time, you certainly can. Right now, I need you guys to transition to page 33 in your packets. I'll give you 30 seconds. Actually, more like 20. You probably already have it out. Okay, so from the very first time I told you about the octet rule, you probably should have known this day was coming. This is the day where we talk about the exceptions to the octet rule. So the fact of the matter is, not every atom actually needs 8. There are a few exceptions to the rule, like in chemistry and any good rule in general. If you're allowed to have fewer than 8, there's only 3 atoms that can do that. That is hydrogen, beryllium, and boron. Hydrogen only needs 2, beryllium needs 4, and then boron needs 6. In certain situations, you can actually expand the octet. It has to be on the 3rd row, so the 3rd energy level or higher. It must be the central atom, and it has to be absolutely necessary. So just because something's on the 3rd row doesn't mean that you can just expand the octet whenever you want. It has to happen in only certain situations where there is no other place for the extra electrons to go. This is called an expanded octet. Okay, so let's do an example with one of the exceptions. You guys should be finished up filling in your notes by now. Let's start with the example of hydrochloric acid. And we're back to another video of some guy who makes chemistry videos for his students. Jeez, what a loser. Okay, so we have HCl. We're going to start with that. And we can see here, after I get rid of this add, that he's looking up the groups. There's hydrogen here in group 1, so it has 1 electron. And chlorine in group 17. What a weird periodic table. What's that hydrogen doing there? Anyways, chlorine there in group 17, not 7. I don't know why he's got 7 on his. All right, 7 valence electrons, so it should be a total of 8. So when you're drawing your Lewis dot structure, whenever this guy gets around to it, he's talking. Okay, there's the H, there's the Cl. He's going to do something weird where he doesn't draw the single bond. He's just going to draw a pair of electrons they share. I couldn't find a better video. I'm sorry about that. But that should be those 2 electrons there, that should be a line. That should be your single bond. And now he's going to add the other valence electrons eventually. There it goes. Around chlorine. Keep going. Thank you. Okay. So, well, it should look something like this. I don't know why he circled hydrogen. But hydrogen only has 2 electrons because it's an exception. It doesn't actually need 8. It only needs 2. Okay? All right, I want you guys to try ammonia, the next example. Ammonia is NH3. Ammonia is NH3. So try the next example. This shouldn't take you longer than like 45 seconds. And you can see if you don't know the chemical formula for ammonia, I just dragged it onto the screen for you. All right, let's take a look at the video on the board. So when you're drawing ammonia, ammonia is nitrogen in the center, and then hydrogen on the all around it, because it's NH3. Remember, hydrogen only needs 2 electrons to be satisfied. It doesn't need 8. So you're going to draw your single bonds. Oh, it looks like he's adding the lone pair on nitrogen first for some reason. Oh, he's doing that weird thing again. Okay, so you see those 2 dots that he has between hydrogen and nitrogen? Those should be single bonds. Oh, good, he's doing it. Great, perfect. Okay, so nitrogen has single bonds, or nitrogen and hydrogen each have single bonds, and then you have a lone pair on the top of nitrogen there for you. Okay, so that's it for ammonia. So I know there's another example on your sheet for boron trichloride. We're actually going to skip that one for now. We're going to go straight to phosphorus pentachloride. So if you're writing phosphorus pentachloride, it should be, dragging it onto the screen again, PCl5. All right, so we're going to see how he draws PCl5. So this is an exception in a different way. This one doesn't need, it needs actually more than 8, not less than 8 like hydrogen. Okay, so he's going to count all the electrons again, and again, it's our friend with the yellow paper. This guy's all over the place on the internet. Okay, so 5 for phosphorus plus 5 for 7 for chlorine, and since there's 5 chlorines, that's a total of 40. Okay, now you're going to notice that he's going to put all 5 chlorines around phosphorus. Now that's a little bit different than what we've done in the past. In the past, phosphorus couldn't have more than 4. But because phosphorus is on the 3rd energy level, it becomes an exception. So there is nowhere else for that 5th chlorine to go, so it actually attaches on to the phosphorus as well. And phosphorate is allowed to exceed the octet rule in this scenario. Okay, only elements on the 3rd row can do this. All right, so if we continue along here, you can see that you just use 10 electrons for each of the single bonds. So that means you only have 30 left. And now he's going to add all the lone pairs around chlorine. So he just used 18, so now you only have 12 left, only 6 left, and now you're done. Okay, so that's phosphorus trichloride, or sorry, pentachloride, because it can actually break the octet rule. All right, at this point, I want you guys to take the exit ticket. I'm going to get rid of this. On the exit ticket, it's basically just going to be used as practice. I don't really have, I'm not going to take it as a grade just because from earlier classes it really hasn't gone very well. So what I want you to do, I want you to put folders up. I want you to use your own periodic table. You can use your project if you like. And I want you to complete this like it is for a grade. This is going to serve as very good independent practice, which has been surprising a lot of people today, that they don't know Lewis dots as well as they probably thought they did when they have to do it on their own. When you finish, just turn it into the 9th period folder, and that's it. Okay, thank you guys so much for being on your best behavior and attention from Mr. Lane. I'll see you guys tomorrow. Have a good day.